So I am Jade Allen, and I am very happy to be here with you all today. I am going to talk about Erlang mostly because I'm an old school Erlang hacker. I mean, I like Elixir, but Erlang, it's my first love. So anyway, so this talk is going to be mostly about Erlang, but you can just imagine that 90% of it, maybe even more, applies just as well to Elixir or any other Beam language that comes on down the road. So in this talk, what I'm really going to try to talk to you about is kind of how it started, right? And how it's going, and then also what can be improved, which I honestly think is the most important and interesting part of this whole talk. But hopefully through the course of this talk, we're going to run into some operational issues that may be familiar to many of you who have also dealt with some of these problems. All right, so let's start talking about how things began. Like most of you, I want to start with a problem statement or describe kind of what our domain is. So we had an application that was gossiping state updates through a P2P protocol layer that we wrote. It's called libp2p. And so what we needed was a way to map P2P addresses that never change to IP addresses, which I'm sure many of you know change frequently, especially if you're running on consumer-grade equipment that's behind a NAT or something like that, downstream. Okay, so our solution to that was a seed node, or what we call a seed node, but you can kind of think of it as a directory, really. It's a set of well-known P2P servers where we sort of hard-coded the IP addresses of those servers into the configuration files for our clients. So if the client needed to find out, a P2P address for dead beef, it could go ask the seed node, tell me the current IP address for this P2P address. And the seed node would respond with a message that said, okay, well, it's at this IP. And then the client could establish a TCP connection to that other node. Now, initially, we had 7 seed nodes, which we thought would be plenty. And when we had a pretty small network, that was fine. And when our clients started, then they would just choose one of those 7 and go on their merry way. And I think it's important to state also that since the list was static, once a client had a seed node or chosen a seed node, it never chose another one again. So there was really no need for that, because there's only 7 of them, and what difference would it make? I mean, in retrospect, that was probably not a great design, but that's kind of where we started out. In general, my perspective on engineering is you choose the stupidest thing that could possibly work and then see if it works. And if it does, maybe it's fine. Maybe you don't need to do a whole lot of complex things. Okay, so anyway, let me talk to you about the seed nodes. So this was our initial deployment environment. We had lovingly handcrafted servers. They were cute and fluffy. And we had artisanally compiled binaries. YOLO, I mean, you could just log into a server and run ErlC, and actually we'd ran Rebar 3, and it would make lovely binaries for us. And then, of course, we had load-bearing tmux, which is surprisingly resilient for small values of resilient. And that's kind of our environment. That was how we ran things for quite a long time. We got pretty far with that setup, actually, disturbingly far with that setup. But unfortunately, what happened to us, or I should say, fortunately, what happened to us is our network started to grow. And so we had more and more clients that were connecting to our seed nodes. Well, we eventually reached a point where we had this thundering herd of clients that were trying to connect to these very small set of 7 seed nodes. And of course, once our clients had chosen a seed node, and if we were especially unlucky, we would have a firestorm of clients all choose exactly the same seed node that was already under pressure. And so, of course, they would have terrible response times, and there would be all sorts of network connectivity problems. And our clients were very unhappy about that, as I'm sure you can imagine. So our response to that is pretty standard. What we did is a crash engineering profiling and refactoring program. We also had lots of YOLO operational changes, and we also started having PagerDuty. Everyone hates that. So, but I mean, in the end, it stabilized again enough. But we kind of ended up in this state where we had this giant, nasty spaghetti of an operational environment. As I said before, we'd made all these changes sort of under fire, and no one was documenting them. No one kept track of them carefully and made sure that we could replicate our environment. So if we lost our seed node, it was going to be a several-day project to build a new one and keep it in line with all of the other ones that we'd already built, because they were one-offs, and even though there were 7 of them, that's all that there were. We reached a point where we needed more than 7, and we also needed to be able to dynamically rebalance all of these clients that were talking to the seed nodes kind of as they came online, right? So instead of choosing one single seed node, we could dynamically sort of route them to something that was a little less pressured or a little more available, right? So there was more capacity to process client requests. And so eventually we reached a point where we can't live with clients and we can't live without clients. We kind of have to live in the middle, the place where Bono can't live. All right, so I know a lot of people, when they talk about server farms, they talk about a herd of cattle. But since we're almost to Halloween, I want to talk about a murder of crows, because that just sounds more spooky to me, and I kind of like that. So how do we get there? Well, first of all, we needed to stop doing YOLO compiles on servers. So one of the things we really worked on, specifically me, was packaging, and 2 kinds of packaging. We wanted to have Docker container packaging, and we wanted to also have Debian packaging. The reason we chose Debian as a format is because all of our servers run Ubuntu, at least for now. We're reevaluating that decision because of reasons that I don't need to go into. But we also needed some other operational pieces to this puzzle, and those 2 tools that we chose were Ansible and Terraform. If you're interested in why we chose Ansible and Terraform, I can get into that later. Just find me and ask me. But we ended up with a stack that included Docker, Debian packages, Ansible, and Terraform. And we used these tools to be able to build our new operational environment, so that deploying a new server became, instead of being a 2-day process, became more like a 30-minute process. And we could spin up a fleet of them. And actually what we ended up building and deploying over time was 50 different servers for seed nodes, because we had almost 1 million downstream clients that were connecting to all of these seed nodes. So we needed a very large fleet of capacity to handle the requests that we were taking from our clients. All right, so I want to share with you some of the tips and things that I ran into when I was building packaging. The first thing is that when you're building a Docker container, you really want it to be as small as possible. And there are a whole bunch of reasons for that. But the most important one is that because the larger your Docker container is, the longer it's going to take to actually deploy out. So if some of you deploy your stuff into Kube, you know that you want that Docker container to be as small as possible so that you can get it spun up and into service as quickly as possible as well. Unfortunately, one of the areas for improvement, let me say, an opportunity, let's go with that, and an opportunity in the Beam environment is working on getting that image size as small as possible. Now, if you go out to the official Beam repository on Docker Hub and look at the images that are available, you'll find one that's called, OTP version -SLIM, slim, right? And that one generally runs Alpine Linux, and it is sort of the base version of OTP for that particular Erlang release. And if you build your containers on top of that, you're going to start out with a base image that's 65 megabytes, because that's just how big the Beam compile is. When you take an OTP release and you compile it, you end up with a container with 2 megabytes of Linux, and then you have 63 megabytes of Docker of Beam files. Sorry about that. So how do we get the minimally small Docker container? Our biggest tip here is to cross-compile. Now, our compilation situation is very complicated, mostly because we had a whole bunch of Rust NIFs. And I know there was a talk earlier this morning, the keynote, where we talked about Rustler for a hot minute. Rustler is really cool, but the Rust build chain is actually over 1 gigabyte in size. And so if you try to just naively build a Docker container with your dependencies crammed inside of it, you're going to end up with a ginormous Docker container, one that is impossibly large for you to deploy at any kind of speed. So what we did is, and this is my secret tip for you, is to use a multi-stage build, which is where you build in a Docker container. That thing has all of your dependencies inside of it, and then you actually take and copy the binary out of that build container into a new production container. And that's the thing that you ship off to your registry for downstream. Okay? So that was our technique, and that was the way that we were able to minimize the smallest possible size, given this sort of constraint of running Beam code inside of a Docker container. Another tip that we found was that cross-compiling is painfully slow, especially if you're doing like an emulated ARM64 CPU. Because reasons, we needed to be able to have Docker containers that were both for AMD chips and also for ARM chips. And our sort of insight here is that having the expense of a build system that runs ARM64 natively was such an incredible speed up. Like our build times went from something on the order of like 4 or 5 hours with cross compiling to like 15 minutes for the full thing for both sets. And that was a huge win. And so I very strongly encourage you, if you're also in a similar situation where you need to supply binaries, Debians, or Docker containers for multiple CPU architectures, it's worth the extra complexity to spin up a build environment that natively runs that other chipset. Jettison everything you possibly can get away with, right? It's all about minimizing size. Sort of one area that is open for investigation is like, what are the default applications that run inside of OTP? Do you really need all of them? Like, how many of you do Megaco? Anyone? Okay, well, Megaco is an application that is inside of OTP. How many of you do SSH like natively to your Beam sessions? Yeah, a couple. Okay, cool. All right, so you people should leave the SSH server in yours, but the rest of you, get rid of it. You don't need it. You're not going to use it. Don't have it in there. It's just taking up space that you don't want to spend on it. So as I mentioned, if you can get your Docker container to be about 70 megabytes, then you should like pat yourself on the back, because that's an accomplishment. If you go up to 85, you're still doing pretty well. If you're over 85, you really need to think about what you can get rid of in your build environment. All right, so that's Docker. Those are my insights into Docker. Let's talk about OS packages for a second. I just want to share sort of an insight that I had. I spent, probably way too much time trying to get the actual native Debian packaging tools to do the right thing. But what I found in the end is that there's this really lovely Java thing, or Ruby library called FPM. And FPM is sort of like an amazing wonder tool that will build you RPMs or Debians, and you don't have to do a lot of configuration with like all these obscure formats and blah, blah, blah. Like if the Debian maintainers like have this huge list of things that you're supposed to fill out and files that you need to create and all this overhead that you just don't even care about. There's a lot of ceremony. So let me just say that. There's a lot of ceremony with building these packages, and you don't really care about that as a packager. You just want to package your application in a way that's easy to deploy for other people. And the people who are consuming your application also don't care about all the Debian package maintainers. Those people have lovely lives, I'm sure, and I appreciate all their work. But honestly, I just want a little Debian package with our application in it. I don't need like the 50,000 extra little files that talk about our license and my social contract with them and like all that kind of stuff. I mean, if you love that, go to town. But for me personally, I just wanted FPM, and I was super happy with that. I also want to encourage you, package a generic configuration file. If your application uses a configuration file, and if it doesn't, like how do you configure your application? Come talk to me about that. I really want to know. Just package a generic file or even an empty file, and I'm going to get to the reason for that in just a second. Also, I would like to encourage you to use systemd. Now, I know a lot of Linux people are haters on systemd, and that's fine. Like, if you are a hater about systemd, I also like System5 startup files. I really do. That's my first love. I'm an old school Unix person, and so I do have a spot in my heart for them. But systemd is like You can't escape from it. It's everywhere, and it's time to embrace it. Systemd has a lot of really great capabilities. For example, something that Systemd is really good at is detecting when your thing has fallen over. So if your application dies, if your Beam VM dies or whatever, Systemd can detect that and will automatically restart it for you. And in fact, it can actually try to restart it several times before it gives up. Now, that capability is really not easy to do in a System5 init file. I mean, it is possible to do, obviously, because it exists, but with Systemd, you just set like 3 things and you're done, and it's just very nice. I also want to encourage you to create a user in a group. So, wherever you're installing these packages, whatever Linux they're going to run on or whatever, create a user and group to own your files. That just makes things a lot simpler for people that are consuming them. They can create their own security policies for them. They can create like access policies for log files, like if there's some sort of help desk situation where non-privileged people need to access your log files, or they need to be able to monitor the operational state of a Beam. That just is a convenience for people who are not you, who might need to operationally manage your installations. And again, don't cross-compile. Cross-compiling is a fool's errand. It's really not worth the overhead. Just run a builder that is that native chipset, and life will be much better. All right. So I want to talk a little bit now about Ansible and Terraform and OS config. Okay, so one thing that we hit a few times was resource limits. So a lot of Linuxes come out of the box with absurdly low levels of open file descriptors. And for most Beam deployments, especially if they're heavily concurrent or use lots of sockets, those levels are way, way too low. So you're going to want to make sure that when you're laying down your Ansible to configure your Linux, that it has an appropriate level of file descriptors and open files in general. So that's a huge thing that we fell into several times. I also just want to encourage you to create roles within Ansible so that it's easy for you to template your config files. So if you have a whole bunch of different configuration, or maybe you have like different applications that go to different sets of infrastructure, it's easier to template those things in Ansible if you create roles for them. And then you can centralize on your Ansible controller where all of those config files live. And it's easier for your developers to sort of synchronize their configuration changes with the templates that live inside of Ansible. Because at the end of the day, when you do a deployment with Ansible, you're going to tell Ansible, install this Docker container with this level, right, with this version release, whatever the tag is. And you're going to say, install this Debian with this version number. And then it's going to lay down a configuration file. And Ansible is really great at those tasks. And so creating roles with those files segmented makes it easier to open pull requests when those config files change or they get extended, right? So we all know that your config file is not a static thing. It's a living, breathing, changing organism. And so that organizational strategy is really powerful. So feeding into what I just talked about, you want to lay down your application. So you're going to tell Ansible, install the file, and then you're going to say, lay down the config. And if you do it in the other order, there's all sorts of weird things that can happen. You will still be able to get a great experience following this advice. So if you install sort of a generic config file that's not configured specifically for your server or for your infrastructure, and then you lay down a specific one with Ansible, that's going to be great. And then all the people downstream, like if they're not sort of internal to your org, like let's say that you're creating these artifacts for other people to use, people who aren't inside of your engineering organization, creating a generic config file will also give them the opportunity to template their own configuration, kind of along the same lines as what I'm discussing here. And then finally, one thing that another foot gun that I shot myself with is always you want to, Terraform is a wonderful tool, super powerful, but you always want to make sure that you validate the plan that it generates before you say, yes, do that, because automating garbage is really hard to clean up. when you've created 50 copies of terribleness, you have a bad day. So you really want to check that what Terraform says you're going to do, you're totally on board with that before you actually push the button that says, yes, please do that. All right, so let's talk about monitoring and logging. We've already had some really great talks at this conference about observability. There was one yesterday, and I saw a couple more today talking about logging. So first of all, please emit some kind of logs in your application. I guess this is self-evident, but I've run into situations where developers have given me code to package where I'm like, where's the logs go? And they're like, what logs? So if that's you and you know who you are, please emit logs. It would be lovely if they're structured logs, because structured logs are really lovely for tools like Loki and some other, Splunk and things like that ingest log files and then tag them semantically so that, poor operational people like me, when the pager goes off at 3 in the morning, we can sort of blurrily log into our cluster and look at those log files and try to see what's going on. Wire up some metrics, same deal here. You really can't manage what you can't measure. Now, we were in this weird situation, so I'm just going to tell you a little story. We were in this weird situation where, because the code that generated our seeds was also the code that literally ran on all of these sort of small, tiny little Raspberry Pis, there was really not very many metrics, because when you're in that sort of embedded space, collecting and emitting all of those metrics really can slow down your application. So I'm not saying that blindly you should always collect metrics, but when you're in an environment where you're running on big server or in a Kubernetes cluster or something like that, and you can export through Prometheus or some other metric aggregation tool, absolutely you should take advantage of that. Anyway, because we were in this environment, we didn't initially ship with a lot of metrics, but once we had the thundering herd coming at our door, we really got into a situation where we needed them. And so we sort of retrofit all that stuff. I can heartily endorse this Prometheus library that I've linked here. That's what we used. It's really quite wonderful. And we haven't had any problems with it at all. It's a lovely library. And if you're writing Erlang, it's a great way to get started with Prometheus at low cost. You want to collect OS and VM level metrics. I think that's a given. And you definitely want to wire up PagerDuty. I think these are all kind of self-evident. So one other thing I really wanted to recommend is, if you're packaging things in a Docker or a Debian file, something that we found was very, very helpful to us, especially in an operational environment, was packaging Recon. Now, Recon is this sort of low-level debugging library that you can use to debug a running instance of Erlang application. We were in a position where on our seed nodes, we could SSH into it and then start a remote console and fire up Recon and get a really good picture of what was broken on the seed node. So we could kind of monitor it as it was happening, as weirdness, as terrible things were happening, we could kind of monitor them effectively and efficiently. So shipping with Recon or another tool like that is really worth the extra space. I know I told you to get rid of everything you can, but honestly, the number of times that Recon saved our bacon or gave us insight into some weird corner case was invaluable. So it's really worth the extra space. It's really worth the extra effort to include it when you're building your packaging. All right. Hello. No. Am I back? Yeah. Hey, I'm back. So if I was queen for a day, what would I change? These are some areas for improvement. Okay, so I've already talked on some of these before. The base beam time is very large, especially when you compare it with Rust or Golang or even Java. The JRE has gotten to the point where, it used to be this giant bloatware, but now it's pretty teeny tiny. So that's an area where I would really like to see some improvement. If there is a way to sort of build a base Docker image that was smaller than 65 megabytes, that would be amazing. I know that there's got to be some room for this, because there are there are people who are running Erlang and Beam inside of tiny little embedded environments, and they've stripped it down. So I feel like there's room for improvement here. The logging defaults that you kind of get out of the box, they're super not suitable, especially for log tagging. Tagged logging is what I meant to say. So, when you're writing your application, that would be the area where I would say is there's the most opportunity for sort of developer improvement operationally, is if you can move to a structured logging format internally within your application. I think that would be a huge advantage for observability and maintainability and operational readiness. File consult style configurations files are problematic. The fact is that, first of all, they terrify people who aren't like Erlang or Elixir people. They are super convenient, but they are hard to template, and they're also hard for people that aren't Erlang nerds to really understand what's going on inside of them. So everyone loves curly braces, right? But I'm just going to blame Mustache. The problem with curly braces is that the curly brace in Erlang stands for a tuple, and in Ansible, it stands for, hey, you should substitute this template variable, which leads you to all sorts of sadness when you're trying to write a template to lay down a configuration on a server or in a Docker container or something like that. If there was some other sort of default like configuration format, if you're looking for suggestions, I personally like HCJSON. I know other people who aren't boomers like Toml. That's fine. Toml, I don't really have a strong opinion about. Just make it not YAML. Please no YAML. My whole life is YAML. I don't need more YAML in my life. And if you're ops, you know what I'm talking about. All right, so some other areas for improvement. The integration between Rebar 3 style source files. So Rebar 3 has this facility where you can write this .src thing, and the startup, so under the hood, I don't know if y'all know this, but under the hood, there's this little bash script that runs, and what it does is it reads this source file, and it kind of looks for environment variables, and it will stuff them into the actual config file that it emits, and then it will start Erlang after that. The integration between that and environment variables is better than nothing, but it really can lead to a lot of problems if you're injecting environment variables from some other source, like Docker environment, or if you do your sort of what they used to have this the 12 configuration, whatever they called that. Some people do their entire environment setup through environment variables. I love that for you, but it is problematic, and it's an area for improvement. I think that there is actually a lot of room for improvement in the area of configuration for Erlang applications specifically, and also the tooling that sits around that in Rebar 3. So, but finally, if you're not already using Rebar 3, please use Rebar 3, especially for Erlang. It just makes things so much simpler for builders and automating builds. If you have some sort of bespoke makefile or something like that, it can be really challenging to get that set up in an environment where you're ready to build packaging for Docker or ready to build packaging for FPM, right? So Rebar 3 simplifies a lot of the packaging work that needs to happen in order to operationalize deployments for applications on Beam. Okay. That's my material. Thank you for your attention. I hope that, that you learned something and had some fun. I'm happy to take any questions.
So thank you for your talk. We definitely have time for questions.
Hi, thanks for the talk. You mentioned Ansible and Terraform. There's quite a bit of overlap between functionality. What did you use for which?
Yeah, that's a great question. I guess I felt like it was obvious, but it's not. We used Ansible to do the sort of OS layer configuration. We used Terraform to build infrastructure pieces. So, EC2, all of our stuff's in AWS, so that's my sort of bias. But we used Terraform to create the cloud environment, and then we used Ansible to configure the cloud environment. So that's kind of where we delineated things at. Things that required configuration or sort of OS level stuff like that, we used Ansible, and things that create servers, create infrastructure within AWS, like RDS instances and Kinesis queues and things like that, we use Terraform.
All right. More questions? Yes.
Yeah, hello. Thank you also for the great talk. I wanted to ask, I don't know if you mentioned it, do you use auto-scaling? Like spin up new machines automatically?
We did have auto-scale policies on some of our infrastructure, especially around RDS, but sort of our server environment, we did not use auto-scaling. And mainly the reason for that is because we wanted to have more control over when things got started. That was the primary concern. Kind of what I found with auto-scale policies is that it's very easy to start new infrastructure, but it almost never scaled down, and it certainly scaled down very slowly. And from a cost perspective, like it got to be quite expensive. So in the end, what we decided was we would just manage it kind of by hand and basically monitor it operationally, and if we needed more resources, we would start them.
Thank you. And maybe quick follow-up questions. Do you use IP addresses or DNS names to talk between the nodes?
So the application uses this P2P layer. The P2P layer is an abstraction, right? So as far as it knows internally, it's talking to a P2P node, but under the hood, it's using Gen TCP to send packets. So I don't know if that answers your question or not. Okay.
All right. One more on the other side.
Yeah, that's right. Make him run around. It's good. That's right. That's right, Sana.
Actually, the question has connection with your run because I work for a gene company, so I'm making my job here, running up to run. We are delivering on this company. We are delivering software for Raspberry Pi. So we're facing these problems with deliver the Beam VM or small computers. Sometimes it's very challenging because I'm not using the standard library. I was talking with David about. Do you think maybe the Beam VM can be more modular? I can pick some parts that I want.
Yeah.
Do you see this happen in the future? Do you know someone want work on that? Did you check if this is possible for some way?
Yes.
What do you think about?
Yeah. So thanks for the question. It's really focused on like, can we make the Beam more modular? Can we sort of pick and choose things? I totally agree with you. I think that the deliverable as it stands right now is too heavyweight. It's too heavy. There's too much by default inside of it. And it would be lovely if it were easier to configure that you want sort of the minimally smallest possible Beam runtime in your containers or in your packaging. Doing that right now is quite an engineering challenge. It is, I'm not saying it's impossible, but it is a lot of engineering effort, and it would be nice if it wasn't so much effort to specify, hey, I'm running this in a Docker container, or hey, I'm using this for packaging. I just need the bare minimum. That's it, And there's not really any good tools for this right now, unfortunately, that could like even profile like what parts of the Beam you use. You just get it all. And in many cases, that's too much. Like you're using the kernel, you're using standard lib, you're using a few things that maybe are outside of that. But in general, you get all this extra stuff that you don't need. And it would be really nice if you could just say, okay, here's what I really need. And I have this tool that can kind of tell me, okay, here are the things I really need to care about in my packaging. It doesn't exist yet.
Yeah, so I'm hearing what you're saying, but I think if you build a release, right? The applications identify all their dependencies, and the release only contains the libraries that are in that dependency tree. So, for example, if you have like recon installed, but you don't include it as a dependency, then in the build that gets in the release tree, you won't have recon.
That's right.
So I think that'll give you. I mean, it's not addressing the problem that the Beam, the language interpreter, isn't modular, right? You'll get all the language interpreter, but it does. Most of the bulk, I think, is in the libraries, in the .beam files. And so if you can, if you've got your dependencies right, you'll get kind of this stripped down release tree. Because what we did at a different company was we had a container that would do the build the release, and then package the release in a RPM. And then that was the build artifact. And then that build artifact was then used to construct the container that would run the application.
Okay. Yeah. So I think that's on the right track. What my own finding is that it's still the case that the base is still too big. Yeah. So I do agree. You definitely want to make your release setup in Rebar as small as you possibly can, including recon. But in general, like the base distribution is too big. That's my complaint.
Okay. And of course, we have one question on the other side of the room. You know,
I love that for me.
Just as a thing, I ran a half marathon this weekend, so yeah, I had enough running.
So now you have completed it. Can you elaborate a bit more about what you would consider parts of the Beam that could probably be left out in certain installations? What kind of granularity would you see, or would you like to see in the Beam? What parts could be left out for you?
Well, just in the base distribution, there, as I mentioned before, there's a ton of different like communication protocols. There's one called Demeter. How many of you know about that one? Yeah, okay, there's a Corba broker. How many of you use Corba? I mean, there's all this stuff that's just been in there for like 20 years or more that we just don't care about or don't use very often these days. I mean, the OTP release is for Ericsson's convenience, honestly. Like they're the people who pay for it. So maybe there's an internal thing there. But like for external people or people that are focused on Elixir or sort of Erlang applications, there's like all this sort of old craft that we can kind of hopefully, please, maybe just like make it configurable. Like I want the classic build, or I want like Coke Zero. Like I want the new cool thing. So that's my hope.
All right. Thank you very much.
Thank you.
We're out of time.